Hello, my name is Jabran Sayed, and I will be talking to you today about area. Well, what is area? First, we need to talk about length. So, what is length? Length is the distance between a point here and there. Well, let's say you're talking to some alien who has no concept of the idea of length. How do you describe this? How do you describe something that they can't just look at and say, "Oh, I get it"? Well, the way we can do this is by describing or by literally counting the number of stuff that's in here. So there is however many, let's say, points are in this line. So however many points are in this line is its length. So let's say that you have a line segment that is 10 points long. And I say points, I'm talking about geometric points. And I know geometric points are infinitely small, and therefore they can be infinitely close to each other. Well, for this example, we're saying that they cannot be touching. So they cannot be overlapping. That means that they are going to be one after another. So that means that there is some sort of gap between them. It's just infinitely small. But that still makes it so that we can have them go in a line in a direction. So these points, let's say this is 10 points long. That means that in reality there are 10 1 2 3 4 5 6 7 8 9 10, something like that. There are 10 points going in a certain direction that are so close together that they merge and become a line. Well, that's all fine and dandy, but how do you get from that to area? Especially if you're talking to somebody who didn't know what lines were. Well, remember how we found a line? We just made it so that a line is the number of points going in a single direction. Well, let's just take that same logic and apply it one step further. So let's take a square. To find the area of this square, one thing we could do is count the number of lines it would take to go from the left side to the right. And it just so happens that since lines are only one geometric point thick, this lines up perfectly with the number of geometric points in this length, or the actual length of the line. So if we wanted to find the area in terms of how many particles or how many geometric points are in this square, in the face of the square, then we would have to do we could say rather that there is one line for every geometric particle. That is, I keep saying particle, I mean point. For every geometric point in this length. So one line, we can use a little bit of math, times however many points there are here. I'm going to say 10. I know I probably didn't draw a 10, but whatever. Times the 10 points. Well, if we want the number of points that are in this entire face, that's easy. We know what this line is. This line is 10 points long, and 10 points times 10 points, that equals 100 points. So we know that there are 100 points in this area. And what's really neat about this is that this simple concept is what integration is. It's like calculus integration. It's just adding 1 each time. Well, these are lines, not 1. These aren't the number ones. These are lines, supposed to be lines. So it's adding 1 line each time until you get to the end of where you're going. Now, that line is going to, and actually it's rectangles, because you can't have an infinitely small point or infinitely small line. Not really. And calculus just says, hey, as this gets smaller, infinitely small, how how many of them can you add up? So that's what area is. There's a dog barking. I hope you enjoyed. Aww.